Right. Good morning, everybody. Happy Friday. I'm Brett Norton with Beyond Clean, and welcome back to those of you joining us for another Beyond Clean virtual conference. And for those of you joining us for the very first time, I'd like to extend a warm welcome to all of you. You're in for a real treat today. The conference title today is Pipes to Patients, Connecting Water Quality to Sterile Processing Success. In sterile processing, we often think of the vast library of complex surgical instruments, sinks, ultrasonics, washer disinfectors, AERs, the list goes on. But the one constant, and arguably to me the most important, is water. Without water, medical device processing would be impossible. And to quote Hank Balch in his LinkedIn newsletter today, without water quality, medical device reprocessing would be absolutely ineffective. I'd like to thank our event sponsor, Verta Water Quality Systems, for helping make this day of education possible. And I'd also like to thank First Case for the collaboration for today's event and providing our nursing credits. Melanie Perry, thank you so much for all your work on that. CE credits will be available for after the conference, and we do have some resources in the upper right-hand corner. One of those resources does highlight how to access the CE certificate. It's a step-by-step guideline for how to get that certificate, so make sure you take a look at that, and it should answer any questions you have. We do have bonus CE content also available in the resource window. And so if you haven't seen that or consumed that for this conference, at the end of today's sessions, you're welcome to jump in and grab 4 extra CEs for sterile processing. Pretty awesome. We also have sponsor-provided brochures and product information. So please take a look at that. There's some good information from the Verta team on what they offer and what they can provide service-wise. Also some housekeeping. Want to let you guys know out there that we are, as you know, we are working in technology, and while we do have some great resources with the technology that we have available, some things do happen. So if you have any issues with audio or video, a really good tool to help fix that problem is to simply refresh your browser. About 99.9% of the time that fixes the issue. So that is it as far as the housekeeping is concerned. I also would like to really encourage questions. We are live, so our speakers are here and available to answer those questions as they come up during their presentations. So please feel free to use the Q&A box and send them our way. So without further ado, I'd like you to sit back, relax, get that sterilizer load started, and it's time for us to get this event started. Kicking off today's conference is Alpa Patel. Alpa is the Director of Scientific Improvement at Nelson Laboratories. In her role, Alpa oversees test method validations, consulting, and operations globally for reprocessing and general microbiology. Alpa has been part of the medical device industry for the past 19 years, and she specializes in the cleaning, disinfection, and sterilization of reusable medical devices. Her presentation title is Water Used for Reprocessing Reusable Medical Devices, a Validation Perspective. Have you ever stopped to think about the water flowing through your department's washers and decontamination sinks? Do you catch yourself wondering what chemicals and minerals your surgical instruments are soaking in? Alpa is here to explain why water quality matters during the reprocessing of reusable medical devices. Get ready to hear the critical steps your department should follow to ensure water used in your SPD is safe for you and your patients. So without further ado, let's welcome Alpa.
Thank you, Brett, for the introduction. Good morning, everyone, and thank you for joining our session today for Water Use for Reprocessing Reusable Medical Devices, a Validation Perspective. I do get a lot of questions from the medical device industry, from manufacturers, and from healthcare facilities and users to understand for us that, hey, how is it that you guys compensate for washers or for water that you use for reprocessing? Do you even consider that? Do you consider these factors that we are using in our healthcare facilities? And are you considering those in your validation? So I'm here to talk about some of the things that we do consider in our validations when we're writing these IFUs that the user community is using to reprocess these devices. Now, for the agenda, we're going to go through a series of different things that I thought was important for the listeners to understand why water is so important and so critical in processing. So we're going to go over types of water used for processing. There are a couple of types that we use, and we use them in those stages as well. Damages incurred through water. There's so many damages that happen, and I'm sure that you've seen them in your own houses. When you see your pipes that turn green, or from the water harness, you'll see the white calcium buildup. Things like that is what is happening also on the instruments. So that is something that I'm going to go over as well. What is the correct use of water in processing? For a long time, I started at Nelson in 2003, right? That was 19 years ago. Water was not thought of something in cleaning validations. And to be honest, I myself didn't know what water played a role in detergents, in steam, in steam sterilization, in cleaning validation, in disinfection validations. How do we challenge those processing cycles? How do we challenge the sterilization? Are we doing the right approach when it comes to cleaning and disinfection or sterilization? And over the years, when I was learning with all of you guys how water played an important role, and how regulatory has given us the backbone on pushing that to the industry and standard committees to ensure that we are making some sort of strides to ensure that there is some stability on how we're doing these validations and how these validations are moving to the healthcare facilities and how they are processing these instruments. So I will also be going through regulatory recommendations. Who is responsible of maintaining water quality, right? That's a big factor. For us in the validation realm, for you in the user, for the manufacturers, who is responsible? And standards regarding water for processing, there are many standards regarding for AERs, for washer disinfectors, for steam sterilization, and there's a new standard that's coming out that the next speaker is going to talk about because she's the co-chair of it. And you will hear a lot about what has been considered. It's been revised dramatically, and I will go over some highlights on that as well. Now to start with why water is important in reprocessing. We all know water is a key quality process, right? Without that, we're not going to get anything cleaned. We have to ensure that the water is in stellar quality when we're preparing detergents, when we're rinsing the devices. We want to make sure that our washers don't have any scaling on it. So that's why we want to ensure that the mineral deposits are not there and there's bacterial contamination is lower. So it's very important to ensure that the key metrics that you're measuring for water, you have that system in your facility to move on with it. Now, water is important in all stages of medical device reprocessing. It's just not important in cleaning. It's also important in disinfection, and it's very important in steam sterilization because that's the last process that is performed before an instrument is used on the patient. So you want to ensure that as you move along the stages, the water is cleaner and it comes to treat it to critical water at the end of the process, which I'll go through in detail as well. Now, poor quality water, you see a picture here. I'm sure you've seen this in your facilities all the time. I have seen them in my facilities for dunnage devices, right? Those are devices that just go in with the validation devices that we put in the washer to simulate a full load. That never gets changed. They just sit in there and they get processed over and over, and they must be processed 500 times. And once they break is when we get new ones. So they do break and they do get rusted. They do get discolored. And I will go over some pictures from our dunnage devices that we've seen over maybe 50 or 100 washes that we have to replace all the time, even after monitoring our water quality systems, right? So there are different stages where you have to monitor these, and there has to be a quality system built in your facility to ensure that these are being monitored. It's not something that you just turn on and forget about it. Now, poor quality of water can lead to rusting, corrosion, pitting, stress cracking, staining. I'm sure you've seen all of these on instruments, and you're wondering what's happening here. Is it sterilization? Is it high temperature? Is it the detergents? Are the chemicals too hard on them? What's going on? Did you ever stop and think that it might be water, right? We don't think about that. We forget the aspect of water and just move towards the harsh environment and think about, oh, it has to be the disinfectant if it is, or it has to be the sterilization pressures and temperatures that are cracking and stressing these. Sure, they contribute definitely to those portions of device, but water also plays a huge role in maintaining these devices as well. Now, here are the three categories of water for AMI ST108, which is a standard that we're working on right now, but AMI TIR 34 is what you're used to seeing. And the TIR is going to be revised to a standard. So I took the liberty to give you just a little snip of what AMI ST108 will say currently for the three types of water. Right now in 34, we have two. Now we've added steam to it. And you may be wondering, why do we add steam to it? Because the end of the processing is steam sterilization most of the time for reusable anyway. And when you think about it, the non-condensable gases, the minerals, the metals that pass through the water can go into the steam chamber and create these discolorations that you often see on the devices or on the trays, the hard water stains that you see on the lids of the trays and on the devices. Those are all there through that system. So it's very important to ensure that the steam portion is also noted and discussed. So that was why it was added. So now you're used to utility water. That's the water that comes out of the tap, right? That may require further treatment, or you just turn it on and just assume the city has taken care of the little things that they have to do to make sure that it's drinkable water, right? What do we use this water for? For the validation side of the world, we use it for pre-cleaning and manual cleaning and automated washing, right? So general cleaning is what we're using utility water for. Flushing, washing, rinsing, preparing detergents, things like that is what we're using this utility water for, which is what users in healthcare facilities are also using. So we also try to mimic what the user end is doing, right? Because we are validating for manufacturers. However, we also have to consider the user perspective in that as well. Now, critical water is water from utility that has been further processed down the road through filters, through processes of water softeners. I'm sure you guys have heard of water softeners, reverse osmosis, test membranes, things like that. And that is used for final rinsing for cleaning validation. And we use critical water after HLD, high-level disinfection processes, right? Because high-level disinfection process is the last process for the validation and also last process before it sees the patient. So we want to ensure that we're using the highest quality of water for processing these these processes, right? So same thing with steam, water that is vaporized in, we want to make sure that in the boiler system, that water is critical water, because that's what's going in those devices, and that's what's tarnishing them, and that's what's destroying them. So you want to make sure you're using the right water at the right stage and right step. Now I'm going to go through each water in a little bit more detail so you understand why these steps are important to have, and why we have the 3 stages of water described. Now for utility water, we all know is tap water, is predominantly used for reprocessing, for cleaning validations, right? Most public water systems at your home, that's tap water that we're using. We're drinking that water. So if it's drinkable, it's fine to use to clean. But what we forget is these water systems have chlorine, have toxic heavy metals like chromium, nickel, mercury, zinc, with all of these in there, and also organic contaminants like life leaves, materials, sand, all of that stuff is in there. Chemicals, bacteria, endotoxins. Depending on the water hardness of the temperature, water can lead to a lot of line scale and corrosion. And so it's very important to understand that all of these things that I just mentioned are in your water, in your utility water. So, and all of those do contribute to patient safety, right? We want to make sure that we're using the right. Now, this is the beginning side of processing, so cleaning validation. We still have, 2 more steps to go through. So using this water up ahead may be okay, but you still have to monitor to make sure that the water systems are lower limits per standards, and so they don't contribute to further degradation as they go on. I've got a little, there we go. And then we have critical water, right? Critical water extensively is treated in a series of steps. And like I said, they go through a series of membranes and systems to make it purified. They're pulling the organics out, they're pulling all the heavy metals out. So now they're softer, and they can be used on devices safely at this point. And they're not going to cause those corrosions, stains, the hard water deposits that you see, the white scaling that you see. And I'm sure you've seen that when you wash your dishes in your dishwasher, right? We see that very often. We have a nice shiny glass when we put them in the dishwasher, but after a couple of washes, you will see that white film that's growing in there. Those are hard water deposits from the water that's in there. Now, when do we use this water? Like I discussed before, we do it for final rinsing and steam generation for sterilization. So that's what you want to remember for critical water. What is my final step? I need to make sure my final step has this critical water. And has this critical water gone through extensive stages where it has removed all of these heavy metals, has removed bacteria, endotoxin. So now it's safe for the patient to use. That's what I want you to take from this, is that there are different steps in water, and there's utility water that is treated by the city, and there's critical water that is treated by your facility. And that is a distinction between both of them. Now, so you may say, okay, fine. Now, how do I know what I need to measure, right? You're saying all this critical, there's utility water, there's critical water. What am I measuring here? How do I know what's the difference between both of them? So they are water characteristics considerations. These are some of the things, I don't have a whole list. If I did, it would be a lot. But if you go to your standards TR 34 and the upcoming ST 108, there are very well-defined criteria for each of these measurements: conductivity, pH, water hardness, microbial level in water, which is very important, bacterial endotoxins, very important, total organic carbon, and water temperature. huge difference in processing, which I'll talk later on. But these are some of the major things that are used for evaluation and used for validation of water systems as well. Now, you might be like, do you guys take care of these in your facility? Absolutely. We measure microbial every week, and we do have 5 different buildings. So all 5 different buildings, we measure microbial level every week. We measure pH, bacterial TOC every month, and conductivity and water hardness, depending on the season. It's due for yearly, but we may do it intermediately. So yes, we do have a system, a quality system for water monitoring as well, just to ensure that the water we are using for processing and other things that we do at Nelson, we do a lot of tests at Nelson, that the water we're using is what is required by standards. Now, I said that AMI-TR 34 details the acceptance criteria of all of these. So you want to remember that this AMI-TR 34 has the acceptance criteria for all of these and how to measure them. They give you a good example of what you're going to do for measuring, how you're going to do it, and what the quality system would look like. And AMI ST 108, which is going to be revised from TIR to the standard, goes in more detail about how you're even going to retrieve the water. What is the sample going to look like? What can you use to measure these? And has given an extensive write-up on how each levels can be used as a measuring tool for your quality systems as well. Now you might be like, okay, you have all these measurements. How is this affecting device processing? So I'm going to go through each one so you have an idea of what I'm talking about. Now, effects of conductivity. When I talk about conductivity, it's a measurement of ions in the water. So all these heavy metals that are going in the water, they have, that's what they call ions. And these are chlorides, your iron, your copper, your manganese, and these are very harsh on metals and materials, right, that are used to make reusable devices. Although they are using medical grade stainless steel, medical grade silicon, medical grade polypropylene PEEK, all of these materials do get affected by ions, and you will see those stress cracking. So even if it's medical grade, it really doesn't matter. They will at some point be affected by the water. And here's an example that straight from my lab, right? We were testing a device, and the outside was beautiful, shiny device, but then it kept failing the tests. And we're like, why is it failing? It looks great. I don't know what's going on. And so we took a boroscope and we looked inside. And when we looked inside, that is what I found. And it was pretty awakening for us, right? Because a lot of times we look outside and we're like, oh, this looks great. It's shiny. It's beautiful. We don't see any hard water stains. It looks perfectly fine. But what is inside is not, what is outside is not necessarily what's inside, right? The metals might be different, right? And the grade material of what's being used inside to what's outside might be different. So you can see that it's not polished. The outside would have been polished, but you can see here that it's not polished. And look at the rust. And also it started to come off. The metals were starting to come off. So that is water detergent damage right there. And this was only reprocessed 6 times. So you can just understand that reprocessing 6 times and you see this damage already means this device is not good for users. So of course we failed it. But it's something that you want to consider looking in the lumens, right? And to ensure that the outside may look beautiful, but you want to look inside and ensure that the inside also looks as pretty as the outside. because when we looked inside, this is what we found. And we only found this because we were doing tests, right? And we were like, why is it failing? Why is it still failing all the markers that we have to test? And that's what we found. So it's very important to ensure that you're also looking inside. And like I've said here, excessive iron and copper can tarnish stainless steel instruments, and the blue-brown surface discoloration that you see is usually created by the copper and iron. Now, further on, water containing calcium and manganese can form hard water deposits, and this is what you'll see on your sink, on your taps, usually. And what happens over time is that these deposits become less soluble as temperature increases and can trap spores and instruments. So what's happening on your faucets and sinks is also happening on the instruments, right? They're probably made of the same stainless steel. Maybe a better grade, but over time it's the same. It will end up becoming the same thing. So you want to put that into context and feel that, okay, what's happening here is definitely happening on the instruments as well. So we need to make sure that the water that we're using don't have these many heavy metals on there. And there should be some sort of monitoring program to ensure that we are below the levels that we're supposed to be. And high metal irons, right? Rust, color changes, corrosion. And you'll hear me keep saying corrosion, rust. And because all of these, when you put together, water is in the middle and everything becomes a web, right? It all stretches out. But it's water which is core of reprocessing. If you don't have the right quality, you just created this big web of problems. And so I like to see it in that context, that here is water, and then we have the ions, and we have conductivity, we have temperature, we have detergents, we have all of these tangents that go all around that we have to worry about. One thing to remember is that heavy metals also interfere with detergent and disinfection efficacy. Very important to remember that, is that it does affect how the detergents work. Detergents have their own chemicals that you put in there. Now you add all of these heavy metals in there, what happens? They bind with those chemicals. And when they bind with those chemicals, they make it ineffective. And when you make it ineffective, what's the point of the detergent? You might as well rinse it with water at that point, right? So you want to make sure that you're using the right quality of water and to make these detergents as well. That brings me to water hardness. Now, I'm sure you guys have seen this, right? And these pictures, right, in your washers. And one thing that we always like to do is, before we even start our automated washer disinfector testing, we look at the spray arms, right? That is one of the checks that we do. We're going visually in there, turning the spray arms to make sure that there is no hard water scale buildup in those little tiny holes that they have. Because if they do, we're not going to get it cleaned, right? So we want to make sure all those checks are there. And descaling, we always have a descaling cycle that there are many detergents that are out there that descale the washer, so they don't have these heavy, chalky, if you know what I'm talking about, materials on the bottom and the sides of the walls. And the main point is the spray arms should be free and dislodged of any of those calcium buildups, which often we see. And I mean, we see it in our lab and we control water, right? So I can just imagine what's happening in the field. And you want to make sure that you do have a descaling cycle that descales all of that. And so we do that at least once a week to make sure that we are removing all of these buildup if there is any in there. Now, why do we have this scale of water? TR 34 specifies, right? It's a TR, will be a standard, and it's still the same thing, is 150 ppm is what's recommended for processing for reusable medical devices, right? And where's 150 ppm? It's between hard, but most of the time, depending on the season, you will see that we're over 180. And soft water is what your critical system should be at, right? That is what you want. You want soft water for critical system. One thing to remember is what I like to talk about when I do STEM activities with young girls. When I'm talking about water, I always say when you wash your hair, when you use just hard water on it, you will see that you will have this crazy hair. But when you use soft water, your hair will be nice and soft and will stay the way it is, right? Same thing with when you wash your clothes. When you have hard water in your clothes, you will see those holes. You may be wondering, what are those holes in my t-shirts? That's happening over time. That's the minerals that are eating through your shirts. So it brings you to a personal level. So I just wanted to give that example. But same thing's happening with metals. It's just going to take time, but it's going to happen. So that's why this recommendation of 150 ppm is what's recommended. And these tests are very easy to do. We do them all the time. There are different types of tests out there, and you just have to measure them before you test. And not every day. I mean, you can do it usually. The rule of thumb here is with seasons, when it changes from winter to spring to summer to fall, you will see the water hardness different at those times, right? And us living in Utah, you see that we're in the very hard zone, right? So we validate here, but devices get sold all over here. So every state will have its own grade of water that's coming out of the faucet, right? Because this is systems in the city. So something you want to remember is that not all of us have the same grade of water coming out. Not every processing facility has the same water that's coming out of their faucet. Florida might have different. Utah, we're hard water, so we're definitely going to have it different. California might have it different. So things like that, New Jersey. So you want to ensure where does your facility sit in? And then you want to sit back and see, where do we fall in with the water? And what are we seeing? And with metals and bacteria and endotoxins and things like that do affect patient safety and devices at that point. Because if the devices are no longer functional, patient obviously is affected by that. Now, pH, you might be like, okay, pH, why are we talking about pH? pH is very important in preparing detergents, right? When we do detergents, most of the detergents we use are neutral pH enzymatic detergents. When I say neutral, we're right here in the 7, 6, 7, 8 zone. When the water that we're using has a high pH or low pH, that changes the scale a little bit. Now, the validations on the detergents that have been done are done at that pH. When you change the pH of that scale by using the wrong water type, that validation is no longer valid at that point, right? So the processing instructions that you're following are, I don't know if it's clean or not at this point, because I used I made sure that when I did my validation, it was at a pH of 6 to 8, which is most neutral pH detergents are at. So that's why it's very important that you understand that pH does play a major role in cleaning validations, because it can alter the pH of the detergent that you're preparing as well. Now, effects of microorganisms. We all know bacteria is bad, and water has bacteria in it, and a lot of waterborne organisms are gram-negative. And what I mean by gram-negative is these are organisms that can cause fever and adversely affect patient. These are, we call, bad organisms that can cause serious illness to patients. And that's where endotoxins come from, is the gram-negative organisms. And these are linked with water. So E. coli, Pseudomonas, Salmonella, all of those are water organisms, Mycobacterium. And they each have their own way of measuring, right? ARs have their own way of measuring these. Washer disinfectors have them. Manual cleaning, all of these, although we don't test for microorganisms for cleaning validations, just disinfection, sterilization, we still monitor our water systems to ensure we are not introducing these into our validations. And that is something that is very important, that you're not introducing a large amount of organisms onto those devices when you're reprocessing, because gram negatives like to stay behind even in processing. And so you want to make sure that they do, those are monitored very, very closely as well. Now, effects of TOC. This is total organic carbon, right? Water contains TOC from microorganisms, plants, animals, pesticides, which are chemicals, and they all have carbon. Anything that has carbon is something that you want to measure for TOC. And why TOC? Why total organic carbon? What is that? That's a food source for microbacterium, right? If you have a carbon source, that is something that the bacteria is going to go to and be like, I got something to live from. So that is what we want to eliminate in cleaning, and that's why it's one of the analytical measurements that we measure when we're doing cleaning validations. I'm sure you've heard about TOC all the time. So this is one of the things that we are always measuring, but they do come in water, right? And they do come in high quantity, and that's why it's one of the measurements that we have to measure. It's a required measurement that you have to measure each time when you are monitoring or you have a quality process. Even if you're doing it monthly or quarterly, it is something that has to be on the list for monitoring. And that's the reason why. Water with high TOC can discolor the device, which we've seen, interferes with effectiveness of detergents, right? Like I said, heavy metals have carbon in it, and when you put that with the detergents, it's going to bind with the chemicals in the detergent and make them ineffective. So they all these play internally a good role in how you're doing these cleaning and processing validations, right? It's not just staining, it's also ineffective of detergents and disinfectants. So it's very important that you have that on your list. And like I said, provide nutrition to microorganisms. Microorganisms love TOC. So if there's any carbon source on your device left, you are inviting microorganisms to come live there. Now you might be like, oh, okay, you talked about all of these different endpoints that we should measure. Now, what's the risk analysis here, right? Now, for product, we're looking at corrosion, pitting, scaling, biomass buildup. Biofilm is a big deal, right? We're now crossing the border on biofilm testing, and we're now talking about biofilm. What does biofilm do? How is that playing a role in processing? A whole new webinar for that, a whole new topic. I can go days just talking about that. Increased microbial load for endotoxin. So if you have all of these different things in there and you're not controlling your water, now you've increased endotoxin. And like we talked about, endotoxin can create, it's a non-pyrogenic effect, right? So it's going to cause illnesses to patients with that gram-negative organism. So very important that all of these measurements are taken care for the product. Now for the process, you have decreased effectiveness with detergents, like we talked about, and degradation of water systems and processing equipment, including filters. When do you change filters for AERs, right? Something to think about. Not when the expiration date is there. So when you start to see degradation. Something we are also talking to about AER manufacturers, that you have an expiration date, but depending on how it's used and where it's used and what kind of water hardness it's coming from the city. If it's coming from the city and going through these filters to make it critical. That's the degradation that's going to happen on the filter. And that is something that needs to be communicated by the manufacturer to the healthcare facilities. And of course, risk, adverse effect on patients. It's indirect, but it's still there, right? Infection, waterborne pathogens. We always see infections with organisms at healthcare facilities. And a lot of them are gram-negatives. And these could be from water systems, right? So there is a possibility. I'm not saying it is always, but there's a possibility that it came from the water system. Toxicity of residual chemicals. If you're not using the right water the residuals are still there. And it can cause burns. It can cause irritation. And we've seen that. We've seen many examples of that. And during other conferences, that there are residual chemicals sometimes left because we didn't use the right water to clean them off. Now, effects of water on device processing, right? What are we looking at? Device malfunction, mechanism stress, so it's not working properly, toxic effects, risk of patient infection, ineffective cleaning because we are not using the right water to prepare detergents, breakdown of AERs, right? Piping, filters, attachment nozzles. Are we even looking at those? Breakdown of washer disinfector, spray arms, pipings, discoloration of devices, right? And AERs is a big one that we want to really, really hone on, is to make sure that the filters are being changed frequently. And why, right? Like we said, the water hardness from each state is different. What's coming in is different, and the filters are seen at a different capacity. So you always want to keep an eye on those filters. Don't change them on the expiration. You have to take a look at them and see if they have been damaged. Now, I wanted to give you an example. This is an example of TAS. I'm sure all of you users have heard about this, and you've seen multiple examples when you go to conferences or when you listen to other webinars. So I bought this example because you're familiar with it, to bring in or to hone in the perspective of why is it important. A lot of times for ophthalmic instruments, detergent's not used, right? They use water. And water quality is important. If you don't use the right water quality, it can affect and create this syndrome. But one thing that when I was researching, I found very interesting was also that detergents and residues from bacilli in water baths of ultrasonic cleaners. These instruments are usually cleaned in ultrasonic cleaners. And detergent residuals from the ultrasonic cleaners can cause that, right? So important to understand it's just not the instruments, but it's also the equipment that we're using to process these devices that are going through, like I said, the AERs, the washer disinfector, the ultrasonic cleaners that I just talked about, that can cause these irritations to the eye. And a lot of time for ophthalmic devices, we do use water. It's because detergents will, if you think about it, if you wash your face with soap and you get soap in your eye, that's a detergent. It stings. So you don't want to use detergents. And if you do, you want to use it at a very, very diluted area. But if you're diluting it out with the wrong type of water, you just created this problem like we just talked about. So you want to make sure that even if you're diluting the detergent to clean these instruments, you want to make sure that you're using the right type of water to do those. Now, like I promised in the beginning of the session, these are instruments from my washer disinfector that are used as dunnage. And I just wanted to give you a perspective and a look of what these instruments look like after 100 to 200 washes, right? They have gone through washer disinfector, just cleaning. And they have been rusted, they have been discolored, and this is effects of water quality in processing reusable devices over time. Not just detergent, the water as well plays a huge role in it. Now, just to give you perspective of correct use of processing, steam sterilization critical, disinfection critical, cleaning utility critical, the last phase of cleaning should be done with critical, some sort of treated water. Usually we use RDI water, and point of use is utility water. So the quality of water, so I just wanted to draw this attention that the quality of water increases as the stages of reprocessing is going forward. So you just want to remember this pyramid scale when you are doing reprocessing. And if the IFEs don't follow this, that means that they haven't been written correctly, and you would have to, I would probably reach out to the manufacturer and ask them, is this the right way of doing it? Now, a lot of questions I do get is, how does water impact your role as a device validation specialist, right? We do take into account that when we're doing validations, we are assuming worst case, right? We have to assume what's happening in the field. And some of the things that we do take into consideration when doing validations is when we do disinfection validations, high-level disinfectants, let's say a Sidex or Sidex OPA that's used over time. Any disinfectants that have a 14-day shelf life, we're diluting that disinfectant with 400 ppm. Now think about when I talked about the slide, the very hard water is over 180 ppm. We're diluting this disinfectant at 400 ppm. So you can just see how ineffective this disinfectant is going to be. And we drop it down to the MEC, which is minimum effective concentration. This is where you dip your test strips, and when you pull it out, it failed. So you no longer can use it anymore. We're just right above that concentration. And that's what we are using. That's what we're exposing the devices for high-level disinfection validations. So we are taking it to the worst extreme case to do these validations. And utility water, we are using utility water to prepare detergents. And yes, we do have detergent water hardness change season to season. Utah sees 4 different seasons, so we do have those. And so we are challenging the detergent as well for the cleaning process. So we are making them ineffective for cleanability, but we're doing the validation to the worst case to show that if right waters were not used, it still can be reprocessed safely. So we do take that into consideration, but as you do it over time, I'm doing this validation one time, but as you reprocess this over time, over and over and over and over again till God knows how many times, right? That will be effective over time. So you just want to make sure that what we're doing the validations, we are taking it to the worst case, but we are also keeping that in mind. Now, using utility water for all steps in testing, end-of-life use testing, right? End-of-life testing, big thing that we're talking about right now. We do use utility water throughout the whole process, just to make sure that the devices, at what point of the time the device will be non-functionable and will break down. So manufacturers have an idea that if they do use the worst water quality system, how long can my devices last? So there is a lot of work being done on the validation testing lab side and manufacturers together to ensure that if something does go wrong and if there's no quality systems, if the water is not there, are our devices going to sustain? And is it going to be safe to process and use that device on a patient? So on our side of the end, we are taking that into consideration. This is just an example of a cleaning validation, manufacturer's instructions and validation parameters. And it just gives you an idea of what we just talked about, right? Rinse under cool running water. We're doing it at greater than 150 ppm, right? Prepared detergent, we're doing it greater than 150 ppm. And rinse devices in treated water, we're doing it less. Not all steps are challenged, but majority steps we do challenge in. And we just talked about this for diluted disinfections, right? 400 ppm, we dilute it, and then devices are rinsed with critical water. So only this step is affected, but the water system, we're still using the right water for rinsing. Now, who's responsible? We all should ask that question. It's me. I am responsible to make sure that the water that I'm using for my validation is what will be used in the healthcare facility and take a worst case perspective. And so we all play a part in patient safety. And this is an example where when we're on floor, it's not my quality inspection that's responsible, right? I was an analyst at my facility. I was responsible to ensure that I'm using the right water. I wouldn't have my manager be telling me that, oh, are you using the right water? I would do it myself just to make sure that we're using the right water for validations. Are we challenging it? How are we challenging? Reading up on it, reading up on the standards, making sure that we're doing the right thing for the patient. So this is something that I feel very passionate about, and I'm sure you all feel very passionate about, that we all take a huge part in patient safety, and we want to ensure that the devices will be safe for patient. Now, standards for processing, sure you've seen this one, AMI Terra 34. Terra has been converted to a standard, right, and to a new standard. Now, ISO 1583, I'm sure some of you have heard about it, but some of you may have not. It's a series, but there is water quality used for AERs are in that standard. Part 6 is what you want to look at. They have a huge section on AER in the back that do talk about what kind of water quality systems they need to do and how they will be measured for a validation. And we do validate that water system. When we do self-disinfection validations, we're also looking at the water quality for it. These are some of the other standards that are out there. Oops, sorry, I apologize. These are also some of the other standards that are out there that you may be familiar with that talk about device reprocessing, water qualifications, water quality systems, and how to measure them and what is required per stage. They do all talk about it as well. So if you don't have this per se, you can look at AMI SC 79, you can look at 30, and 12 as well. These are some of the references that I used for my presentation. And if you want to hear more about validations and how we're doing validations for reusable medical devices, we do have Sotera Health Academy that also talks about different processes we use, how we validate medical devices, and what considerations we take. That takes me to the end of my presentation. I'm happy to take on any questions they are. Thank you.
Okay, Alpa, that was great. I would say that my nerd brain when it comes to the chemical side and water was turning throughout the presentation because there are a lot of those questions, especially related to pH scale and you know how chemicals can be altered and with the difference in water pH is something that I've run into plenty of times. But since we only have a few minutes here, I want to make sure to get to as many questions as possible because we have a lot of them. So this one is closely related to what I just talked about, but this comes from Jesse Lopez. Jesse, shout out from our team here. How does each type of water affect chemistry for cleaning, tap versus critical water, and would using critical water be beneficial to use during the cleaning step with chemistry during manual or automated processes?
So that's a good question, Jesse. Usually it is not required. Of course, it's great, right, to use critical water for processing. Everybody wants to do that, but it's not required. It takes a lot of processing up ahead, which is cost. All facilities have to bear the cost. That's a big one when it comes to treating systems, right? So it's not required because when you go down to the processes, cleaning is the first step, very important step, agreed. But as you move down, we are using critical water, right? The final rinse of cleaning will be done with critical water. Then with disinfection is critical water, but if it's sterilization, it's also, you want to make sure it's critical water, like I said. Not a lot of people look at sterilization boiler systems to make sure that the water in there is critical. They just pull in the tap, push it through in, and that's what's used. But ideally, of course, it's best. But realistically, with the cost perspectives, and I mean, cost shouldn't be linked to patient safety, totally agree, but it's what is feasible for that facility, basically.
Right, and I think you make a good point when it comes to cost because having the water treatment systems is not necessarily cheap. It's very important, and I think it's going to be more and more important as we go forward. But as of now, when budgets are such a concern and we've got a lot of things to consider within the departments as far as efficiencies are concerned, that's, of course, one of them, but it's not the only thing. So that's a good point. Jesse also had a follow-up to that question in regards to the pH side of things. So how big of a pH change in water would affect chemistry? Are we talking 1 or 2 points or 5 or more? Chemical is
I would
neutral.
say...
Okay, go ahead. Go ahead.
I would probably say if you are at 3 on both ends, you just have changed the chemical at that point. And so 1, probably not. 2, maybe. But when you're at 3, that's a problem. So we want to make sure that that is not at that level. Yeah. It just alters the chemical reactivity.
Right. So a question from me that might be beneficial, how do we test pH? Are there easy, a test strip that you can dip in?
Yes.
So, yep.
Yes, that's what we do, right?
All right.
We don't have those fancy meters that we do have them in the lab, but they take a while, right? And
Right.
in a fast-paced environment in a healthcare, we don't have time to put on those monitors and check them. So we're looking at test strips. We're just putting the test strips. Good enough. Let's keep going. So that's how we're doing validations.
Great answer. Here's another one from Anne. How should we address concerns regarding increased water temperature due to excessive heat, weather, especially concern with the pH in Lyme, due to Lyme, and that's probably down in the Texas region. And I think there's already a high level of Lyme deposits down there. So I guess, that I would say that probably falls in the line of a water treatment system.
Yes, it does fall in line in the water treatment system. That is that is not something that we can control. That would be a city thing for. Yeah.
Right. All right. Let's see. We've got a few more minutes, so let me touch on a couple more of these. How do you feel about adding vinegar to water for processing?
Very interesting. Very interesting. We've done vinegar for processing for home care instruments before, because you usually for baby things, for baby stuff that we've done that. You could. What happens with vinegar is that it is high. Not high, but it is in low acidic. The pH is very low there. It may clean, but over time, if you are looking at a different, like a peak of polyethyl material, it will cause stresses. It will start to break it.
Will it alter the pH of the water?
Yes, it will alter the pH of the water.
Yeah. So that's another consideration. There's all kinds of things to think about when you're talking water quality and pH levels. So let's see here. Do sequestering agents and chelating agents work to hold back metals and prevent the damage that you discussed in your presentation?
So they are systems built in that do have chelating agents in there. There's water softeners, there's carbon beds, there's all these different systems that are built that do have chemicals that will strip them out of the water. So if you have those systems built in, then yes, it will help with that process.
Great. Well, Alpa, I think we are just about at time. And for those of you who didn't have your questions answered, I'm seeing a lot of questions that will be able to be addressed throughout the day today, because we've got some great presentations and panel discussions coming up. So please stay tuned throughout the day and make sure to throw those questions back at our speakers. And if you would like to contact Alpa directly and have her answer those questions, I'm sure she'd be more than welcome to do that. Her contact info is located in the bio section on the right-hand side of your screen. And Alpa, I'd really like to thank you again for joining us today. It's been great to have you once again, and another informative and excellent presentation. I'm sure our audience is going to take a lot from it.
Thank you. Appreciate it.
All right. Okay, everybody. So please stick with us. We'll be here for the rest of the, not the entire day, but a good chunk of the day. And we've got another 5 great sessions coming your way. And I've seen them. I've not been able to sit through them. So I'm really excited about really learning from our presenters for the rest of the day. So stick with us. We've got about a 15-minute break, and I'll see you on the next round. Okay, thanks.